All right, so on this problem, we're going to solve using heading and bearing information. We're going to round to the nearest mile if necessary. We've got two airplanes leaving airport at the same time on different runways. One flies on a bearing of north 40 degrees west at 110 miles per hour, and the other airplane flies on a bearing of south 30 degrees west at 190 miles per hour. How far apart will the airplanes be after 1 hour? So remember, when you're looking at these, that north and west part means that we are going on a bearing of north 40 degrees west. So 45 would be about halfway between there. So it's not going to be quite that. And I'm going to mark this as 40 degrees. We're looking to how far apart the planes are going to be after 1 hour. I know it's going at 110 miles per hour, so I'm going to write 110 miles because that's how far they're actually going to be. The other plane is going south at 30 degrees west at 190 miles per hour. So a 30-degree angle, and these are just sketches, so they don't have to be perfect. This is going to be 30 degrees, and I know that it is flying 190 total miles. Now, I need to solve this. I'm going to actually use the law of cosines because I don't have a right angle here, so I can't do it that way. And I don't want to try to do the law of sines. So I'm going to use the law of cosines here. So the first thing I need is I need an angle, because if I'm looking for the distance between them, I'm looking for the distance between the planes right here. So what I need is this angle. And how am I going to find that? Well, if I look at this straight line from north to south, that's 180 degrees. So if I take 180 degrees and I subtract out the two angles I have, I will get the value of this angle. So my angle is going to be 180 minus the 40-degree angle and the 30-degree angle, which will get me 110 degrees. So I know that this angle is 110 degrees. Now that I have the angle and I have the two sides that are not, so this angle, we can call it angle A if you'd like, and this will be side A, this would be my B and C, and it doesn't matter which one's B and which one's C. So I'm going to write our law of cosines formula. So A squared is equal to B squared plus C squared minus 2BC times the cosine of A. So my A squared I'm looking for, or my A value, is here. So I'm going to have A squared is equal to, it doesn't matter which one I put first. I'm going to go ahead and put the 110 squared plus the 190 squared minus 2 times 110 times 190 times the cosine. My A is going to be that 110 degrees. Now the reason it doesn't matter which one you put as 110, 190, 190, 110 is they're being added and squared and they're being multiplied. So that won't matter which one comes first because they're not actually labeled as an A, B, and C triangle over here. So we're going to figure out this whole value by putting it in a calculator, and we get A squared is equal to 62,496.44. We're going to take the square root of both sides, and A is going to be 249.99. Now, we didn't worry about plus or minus because, again, we're talking about a distance, but it said in our problem to round to the nearest mile if necessary. So A is going to be equal to 250 miles. And that would be your final answer as to how far apart our airplanes are in 1 hour.